This video is part of a series. It's heavy in scientific terminology and may expect familiarity with previous videos. If you're confused, please watch the rest of the playlist up until this point, or check out my genetics terminology document, both of which are linked in the description. Thanks! The E locus stands for extension, and it's another one of those you'll hear about this one no matter what mammal you study loci. Scientists call it MC1R, and it's a gene region with a lot of versatility that can do some wildly different things in different animals, mostly controlling what is and what isn't allowed to have eumelanin in it. The K locus is also on MC1R, but it's in a different place on MC1R, so it's a different locus. I'll talk more about this in the next video, but a quick note on red, there's a lot, and I mean a lot, of polygenetic variation on what red looks like. It can be super, super deep, almost liver adjacent, and it can be mistaken for white or anything in between. Just like previous videos, you're going to see dogs all over the spectrum used as examples in this video. Don't get confused. If I call it red, it's just red, aka caused by pheomelanin hairs, even if it's a weird red. Got it? Cool. First in the dominance order is EM, for extension mask, which gives the dog a quote-unquote mask of eumelanin hairs. It matches the rest of the dog's black base color, so if the dog is liver, then it's a liver mask. Same for other eumelanin modifiers I'll talk about in future videos, like blue and merle. This mask can show up on pattern dogs and hide part of the pattern, like these point dogs who all have black faces. If a dog with the EM allele is already solid black base, either because of KB or because of recessive black, they will technically still have a mask, but we can't see it on account of the dog already being all black based. For this reason, we say that both dominant and recessive black are epistatic to EM. A black mask can just be the tip of the muzzle, or it can extend to cover the entire face and go down the chest, possibly even add eumelanin hairs to the ears, back, and in extreme cases, the tail and paws. Variation here seems to be just a bunch of unknown polygenetic modifiers that hopefully we'll understand more someday. The intensity of the mask can fade as the dog ages, but it won't always. Also, dogs who have masks, sable, and piebald, aka white spotting, sometimes have a kind of faint black border between their red fur and the white fur, called etching. This might be because the presence of unpigmented white areas affects how, in fetal development, the eumelanin that would normally go to the chest or paws instead has to spread out and find their homes elsewhere, but this is just speculation and we don't know for sure. Next in the dominance order is capital E. This is just a normal dog with nothing silly going on in extension. Carry on. After that in the dominance order? We don't know. Traditionally, the alleles EA, EG, and EH were all thought to be one single allele, and we just found out that there's 3 of them, so we don't know their dominance order to each other yet. And we probably never will because they're found in different breeds and people don't like mixing those. But we do know that they're all recessive to capital E and dominant to little e, which we'll get to last. They all cause variations of domino, wherein the dog's red pattern gets extended. This can look kind of like the mid-ish stages of creeping tan, but it doesn't creep. Also, unlike creeping tan, it affects all A locus markings, not just point and wolf gray. Just picture the A locus marking of your choice and kinda push it back so it's bigger. That's domino. Most of them end up forming a kind of widow's peak at the forehead or a stripe down the nose that are considered characteristic of the phenotype. Dogs with domino may also have a pink stripe down the center of their nose, but not always. Domino does this crazy interesting thing to brindles, where it makes the brindle cover their black base markings instead of their red base markings like usual. So what about solid black dogs, who don't have any pheomelanin markings to increase? It seems that domino isn't content with having nothing to mess with and just makes its own pheomelanin markings. It looks a little similar to tan point. My source for this comes from a Siberian Husky genetics website, though, so I don't know if that's true for other breeds. It's also worth noting that their example is a KYKY little a dog, aka recessive black, so I'm not sure if this also goes for dominant black or not. I would assume so, but I'm not sure. Despite all 3 causing domino, each allele here causes a slightly different variation of domino. EA is described as northern domino or ancient domino, and EG is grizzle domino. Apparently there might be a mild incomplete dominant situation with capital E, where a dog whose heterozygous capital EEA or capital EEG might show some slightly bigger red markings than a capital E homozygote, and might have a slight pink nose stripe. The Siberian Husky website I mentioned earlier was talking about EA specifically, by the way, so I don't know if EG behaves differently with solid black dogs or not. Sorry. EH is exclusive to Cocker Spaniels, whose breeders call it Sable because dog breeders do not communicate. It's called Cocker Sable. It's a very strong version of Domino. Remember, the other two Dominos act on red markings, pushing them a little bigger, and they give solid black dogs point-like red markings. EH, however, takes any red marking and just turns the dog almost totally red, like a Sable. Even wilder, EH on a solid black dog gives them crazy high red markings. I want y'all to know that it has taken every ounce of my effort not to pronounce EH as at any point during this explanation and say that it turns the dogs Canadian. You're welcome. Moving on from Domino, we know for sure that this last allele is fully recessive to everything else on E. It's even in the name. Recessive Red is caused by little e and it's epistatic to everything! Okay, not everything, but it entirely erases eumelanin from the fur, leaving the dog totally red. This means no matter what the dog has on the K or A loci, if they're homozygous little e, they're just red. No few black hairs on the back like a clear Sable either. No stray Sable hairs, just red. This also means that Recessive Red totally hides everything that modifies black. On the fur, at least. Their leathers, which are always black-based, will still reveal a Recessive Red dog's hidden black-based color. Evolutionarily speaking, whiskers are modified hairs, so even though a Recessive Red dog's leathers are still black-based, you can often tell a clear Sable apart from a Recessive Red dog by looking at their whiskers. A Recessive Red dog's whiskers won't be black-based, but a clear Sable's whiskers will. Another way to tell clear Sables apart from Recessive Red is if they have a mask. Remember, EM is dominant over little e, so if a dog has both EM and little e, only EM will express and little e will just be carried. So if an otherwise all-red dog ever has a mask, they must be a clear Sable. There are actually 3 different versions of little e, E1, E2, and E3, but they all do exactly the same thing and inherit exactly the same way, so we just lump them together and pretend they're a single allele. Here are some practice squares. First, a masked dog, and a regular dog with nothing silly happening on extension. Nice. A bit complicated, isn't it? But it looks more complicated than it actually is. Let's break this down. 50% chance that this puppy will genetically have a mask, since EM is dominant over everything. Of course, if the puppy is black, we won't see it, but it's there genetically. And there's a 50% chance that the E locus won't do anything at all, since capital E is dominant over little e. So even though one of the parents is carrying Recessive Red, there's no chance that a puppy from this pairing will express it. What's fun is that it's entirely possible that this pair is a wholly black and wholly red dog, respectively. If the EM having masked parent is black, their mask is invisible, and if the capital E little e heterozygote parent is a clear Sable, they'll just be red. So this potentially all-red X all-black pair can produce a red puppy with a mask. Of course, that's far from the only possibility. It could be a point dog with a mask and a wolf gray, or a wolf gray dog with a mask and a dominant black dog, or 2 black dogs. Lots of fun possibilities. For this next square, I want you to tell me the parents' phenotypes as well as the puppies. Excellent. Again, the parents are a masked dog and a nothing on extension dog. Once again, we have a 50% chance of their kid being masked. We also have a 25% chance of a kid whose extension isn't doing anything weird, but this time there's another 25% chance of a fully recessive red kid. Even if both parents are like solid black with crazy eumelanin modifiers or brindle or something, if that last 25% hits, we won't see any of it on baby, because their recessive red will hide all of it. It's still there in their genome, but hidden, carried, except for their leathers, of course. Next video is going to cover the many dilutions that dogs have. I'll see you there.